So Mark, why don't you explain to us this contraption system you have, test system you have here?
The aardvark. This is actually a thermal control unit. This is a T, or nickname it TCU. Okay. We can control the device, the temperature of the device under test from negative, I believe it's negative 80 C up to 260 C.
Okay.
We're not just at the for a period of time and bring it back. It's not a thermal chamber. It's actually we control the temperature of the device while it's being tested.
Okay.
So we simulate the atmospheric condition in which it's designed to be used, particularly aerospace military. When you're up in...
So these are the temperature levels going from 150 C down to 20, like down to negative 50 C. That's what it's
doing. We're testing the device at negative 50 C.
At negative 50 C. Oh, yeah. Wow. Okay.
Yeah. So it's actually connected. There must be a capacitor in there because we're using an LCR meter on it. Sorry, it's a resistor. So we're testing the resistance value of the device while it's at... Right now it's at 25 degrees C.
Okay.
So the process is we take it from ambient, then we go down to negative, then we go back up to ambient, then we go back up to positive, then we come back to ambient, and we test it at each step. And you have to hold the device at that temperature for a period of time to make sure that the inside of the device is the same temperature as the atmosphere around it.
Okay. So on that end, I mean, I can say in the market coming into place, so really a component that is not a substandard will not stand that temperature testing, right? When you go into those high levels, that's when you find the easy failures would be easy to see. That's substandard.
And that's probably where we see a vast majority of the counterfeits are devices that are like a commercial grade, but they're being sold as an industrial or as an aerospace grade. At ambient, they may test the same, but you see the difference when you test at temperature range. Okay. A device that is a commercial grade device is likely not going to work at the Minimax operating conditions that we see in it for aerospace and military, or even automotive and industrial.
Automotive grade, yeah, industrial.
That's probably the most counterfeit areas. C's remarked as I's and
yes, correct. Especially as important it is getting into aerospace defense or automotive grade. I think this, as I said, these test protocols really can differentiate any component to what it is for the material composition. It's not, as I said, you don't have to actually test electrical standards at some point. You can put it in there and say, first of all, does it pass the temperature range? That's and as I said, that's the key.
To have the right capacitance values at the
temperature range.
So last year was crazy with the MLCs. We're just going, not commercial, not commercial, not commercial. But they're all being sold as automotive grade. We're like, no, they're not.
Yes. That's good. Very good.
And that's just one of the sequences of test stations that we have built throughout. So we've got everything from the active discretes, passive discretes, linear, analog, mixed signal, advanced digital process, as well as processors.
Okay, I can see she's doing some testing right now, or she's moving some components around.
Oh, yeah. She's doing actually testing. These would be active discretes. We use an automated test system, so we can test all the active parameters on an active discrete.
Okay.
With the MLCCs last year, we see a lot of shorts in the active discretes, particularly the high-power active discretes. So what we were seeing last year particularly was devices that are low power being sold as high power. So like a 5-amp MOSFET was being sold as a 20-amp MOSFET. And the only way to know that is if you're actually testing it at 20 amps. What we see, a lot of people have the capability to test in milliamps. You can't test a 20-amp device at milliamps. You have to test it at 20. We have the capability to go up to 100 amps for testing conditions, as well as 2,000 volts.
Oh, wow.
So we see a lot of low power being sold as high power. And on the outside, it's still a TO220 package. They're going to look the same. But it's on the inside where the functionality is different.